Alright, here's our last graph for the day. It is y equals x root 16 minus x squared. Once again, you aren't expected to know what this looks like. Y equals x and y equals root 16 minus x squared. We know what they look like individually. Now we're going to see what it's like when we multiply them. So once again, we've got a function of x multiplied by another function of x. So it's going to be the product rule again. So x root 16 minus x squared. So we've got our first function is just going to be x, and du is going to be 1. Just move those over. V equals, and I'm going to write this in index form. So this is going to be a chain rule or function of a function. So my power comes down the front. My power goes down by 1. And I multiply by the derivative of the thing in brackets, which is minus 2x. So I can tidy that up. The half and the minus 2 are going to cancel out to be minus x. We've still got a power of a half. The minus puts it on the bottom of our fraction. So minus x on root 16 minus x squared is our dv. Alright, so to find our first derivative, u dv plus v du. So we get our root 16 minus x squared, and that's times by 1. And then we get our x, okay, our u term multiplied by our dv term, which is minus x on root 16 minus x squared. I can tidy that up a little bit. Root 16 minus x squared minus x squared on root 16 minus x squared. So the next step is to put that equal to 0 and try and find if we've got any stationary points. So we know to find stationary points, we set our first derivative equal to 0. So that's root 16 minus x squared minus x squared on root 16 minus x squared equals 0. And what I'm going to do is split these two terms up. So my next step, I'm going to multiply both sides, just make a note here, by square root of 16 minus x squared. So what we're left with on the left-hand side is just 16 minus x squared, and what we're left with on the right-hand side is just x squared. So putting all that together, we get 2x squared minus 16 equals 0. So solving that, x squared equals 8 and x equals plus or minus root 8. So they are our turning points, potentially, points of stationary points anyway. So let's find our y coordinates. So I'm going to put this in as a formula. So it is x, which I'm calling a, times, we've got a square root, 16 minus a squared. Now it's complaining because it doesn't know what a is, so I will tell it. I will tell it that a equals root 8. So if a equals root 8, then my function equals 8. So when x equals root 8, y equals 8, and let's just see what happens when x equals minus root 8. Our y value is minus 8. So we've got minus root 8 minus 8, and we've got root 8, 8. Now, what we could do here would be to find a second derivative and use that to examine the concavity at these points. But if you look at that first derivative, that is very unpleasant, and I certainly wouldn't want to be differentiating that again. So what I'm going to do is I'm going to look at the gradient. I'm going to use that first derivative, and I'm going to use that to see if my gradient changes. So what I know is we've got a stationary point, and ditto, we've got a stationary point. So let's test either side. Now I've got to be careful here. I might take myself a new line, and I'm going to put in the first derivative. So the first derivative, and I'm going to do the first derivative in terms of b. So it's going to be root 16 minus b squared minus, so whenever I see x, I'm substituting b, so b squared on, well, that was nice, and this is root 16 minus, and again b squared. Now it's complaining because it doesn't know what b is, and that's true, I haven't told it what b is. So what we want to test is either side of root 8. So before we can test either side of root 8, we actually need to know what root 8 is. And it's, it's between 2 and 3. So minus root 8 is between minus 3 and minus 2. So if you've got minus 3, minus root 8, and minus 2, and similarly for our positive one, 2 root 8 and 3. So if we test b equals negative 3, the number isn't important. It is negative, which means that before we get to minus root 8, we're dealing with a decreasing curve. We know we've got a stationary point. We just want to see what happens on the other side. We want to see what happens at negative 2. When I substitute in negative 2, I get a positive value. So that means that this minus root 8 minus 8 is a minimum. And on the other side, testing 2. Notice these same numbers are coming up. I suspect we might be dealing with an odd function. So it's positive there. So an increasing function. Flat there, and if we substitute in 3, it is negative, so decreasing. So we've got 2 stationary points so far. Let's have a look if we can find any intercepts. So to find the x-intercept, we substitute y equals 0. So that means x root 16 minus x squared equals 0. And when that happens, divide throughout by x. 16 minus x squared equals 0. Square both sides. 16 minus x squared equals 0. X squared equals 16. Don't do this. Take a new page, take a new line. X equals plus or minus 4. Alright, let's go to our graph. Here's our negative 4. Here's our positive 4. So we've got those intercepts. So the last thing we're going to look at are restrictions on the domain, because that function has a square root in it. So let's see. Now I've already drawn root 16 minus x squared. It's a semicircle with a domain between negative 4 and 4. And that's what we're going to have for this as well. So restrictions on the domain, you can't have something under a square root sign being negative. So 16 minus x squared must be positive. So that leads us to that x must lie between negative 4 and 4, or using our brackets, square brackets, because we're including those endpoints. So there's no point substituting in 5. In fact, if I tried back here, substituting in 5, undefined. So I might just clear those and just put in some other values. So if a is 3, I get, sorry, I might do negative 3 first. A is negative 3. We get minus 7.9. So thereaboutish. Now root 8, it's about 2.8. So remember that we've got that minimum very close to there. So let's just stick a few other numbers in. Let's stick in negative 1, and I get minus, let's say minus 3.9, close enough. We've got our 0, 0, and we've got the same on the other side. So let's put this all together. So at root 8, which is about 2.8, we get to 8. So now the tricky bit, trying to join all these with a nice curve. So here's our minimum. Intercept. And by the way, when we looked for intercepts and we found -4 and 4, we didn't find x equals 0. And the reason for that is we divided throughout by x, which means that we didn't find that result. Alright, so that's it. That's a lot of work, and that I think will take you through till next week, and I'll see you then.